Hello everyone. Good morning. Sudeshna, Monica, Vardhan, Yashashwini, Sai, Nandini, many more are there. Names are very difficult to pronounce. So, good morning, good morning. How are you all? All good? Sir, add score 1 right. In which one? Track 1, track 2? Huh? Correction. Chemistry nil by no changes. Chemistry LT goal page 2 no key changes. ठीक है? No key changes. Valence shell electron and valence electron question. That incomplete octet and all. Chalo, we will discuss the question at last. ठीक ना? Otherwise you can message me. I will tell. Space you are saying? Okay. Space so I will have to see once again then. Okay, रुक जाओ. Wait. Space. I'm not able to see anything. Space claims till now not there. Chalo, space we will see, not given till now. Space. Chalo, if it will come, we will see it. Okay? So chalo, let's start first. We were in middle of something. And what was that something? That something was hybridization. Number last lecture we have said. Okay? See the last lecture video at end I have told. Hybridization, correct. So I told you just about the table, na, ki steric number, based on steric number you can tell hybridization, but we have not set the points of hybridization. So we will try to say all those points also. Bolo. Online exam option is there or not? All these things we will have to discuss to Prasad ji. Online exams only I think students are giving, na bhai? Those who are giving from app only. Okay, so let's talk about one thing. First thing we will talk about that methane molecule. And we will go to that table also. So I think in that table we have made like this. Ki steric number was there. Steric number 2, 3, 4, 5, 6, 7. And we will talk about hybridization SP, SP2. Here we have said SP3 also possible and DSP2 also possible. Then we said SP3D or it can be DSP3. It can be DSP3. Then we said here also you can have SP3D2 or you can have D2SP3 and here you can have SP3D3. Bolo, correct? All good. Then we have written here bhaiya geometry we have written. Electron pair geometry, you can say molecular geometry. जो बोलना है बोल लो भाई. Molecular geometry लिख देता है, ठीक ना? Molecular geometry. So SP is what? Linear. ठीक है? So SP is what? Linear. This one was trigonal planar. Na? Some questions came based on this, but I think what we have told that was sufficient to do. From that we can do all those things. Trigonal planar. ठीक है ना? And SP3 is tetrahedral. DSP2 is square planar. and sp3d2. देखो रे, what is this? dsp3 and sp3d 5. I have told you steric number 5 means I require 5 orbitals. So sp3d, this one was tbp. We have written here only tbp, but now I will tell you ki two things are possible in this. Two things are possible in this. One is tbp, which we study. The other thing is also square pyramidal. This we will not tell, it is not there generally. ठीक है ना? So mainly you have to focus on this part, tbp topmost priority. ठीक है ना? Then sp3d2 we have octahedral, and sp3d3 we have pbp, pentagonal bipyramidal. Clear? I think everything is good. Then we have told you ki which orbitals will be involved. Like especially I told you about this dsp2 ki which d orbital is there. Can you tell me? Bolo bhaiya, can you tell me which d orbital is there? Acha, classes also started on app. ठीक ना? So I think in 1-2 days they will stop doing this on YouTube. So we have said dx square y square. Chalo, theek hai. If you are saying dx square y square, then I told you what tbp. tbp is there, then which d orbital? Bolte raho. Tell. Quickly tell. So this is what dz square. Correct or not? And octahedral is there. Octahedral. Then I told you dx square y square and dz square. Both. Na? That's it. And you can also say here, you can also ask, sir, dx square y square to find s orbital and which p orbital. You can say I will take px and py. I will take px and py. So orbitals also you should know. Orbitals also you should know. Clear? So this much we have told you. Based on steric number, you can do the questions. ठीक है? And then I will ask you one more question. That question is regarding methane. Methane, we know all the CH bonds. I think, hope everyone knows till this point. यहाँ तक all clear. ठीक है? Okay. Now methane, we have discussed in last class कि how methane should be formed. ठीक है? And we said कि sir, one bond is formed by SS overlap and 3 bonds are formed by SP overlap. That came in the paper also कि without hybridization, without hybridization, भैया, what is the story? Story is like this कि 1 sigma bond should be formed by SS overlap and 3 sigma bonds should be formed by SP overlap, and you are having 2 types of bond. Correct na? Bolo, this point everyone understood in the last class or not? This point everyone understood in the last class or not? Correct na? Correct. All correct. Okay. Acha, can you also comment on the bond angle here? Without hybridization, what should be the bond angle? So we'll have to say like this कि bond angle should be 90 degree. Without hybridization, bond angle should be what? 90 degree. Because you are knowing कि px is there, py is there, and pz is there. They all will come to form the bond. Px is along x-axis, py is along y-axis, pz is along z-axis. Then they are mutually perpendicular to each other. They are, you can think like this. देखो. You can think like this कि sir, these are the axes. देखो, suppose this one is px, ना? This one s orbital will overlap. Suppose this one is py. then one s will overlap here. So angle between them is coming what? Angle between them is coming 90°. If we are using pure orbital, then the angle should be 90°. Acha, same thing you can explain for water. Similar thing, ammonia. There is one question in gym material. Which of the following compounds show sp overlap? One question is there. I am writing that question also. Dekho. Which of the compound show sp overlap? Which of the compounds show sp overlap? And your options are like methane, second option is ammonia, and third option is water. So if you see till here only, then though you will say ki sir, everyone showing sp overlap. Correct or not? Because see sir, hydrogen will bring s orbital, confirm, and these carbon, nitrogen, oxygen are having s and p orbital. So all will do sp overlap. So here the fourth option should be all of these. Then you can tick all of these. Okay? But the fourth option is present here is none of these. Fourth option is what? None of these. Ab batao, how none of these coming? Fourth is what? None of these. And correct answer is this one only. Because these are theoretical thing. If you will think SP, then angles will not match. I have told you in water there is 104.5 degree, ammonia 107 degree. If you will take pure orbital, then the angle should be 90 degree. So to explain all these points, bond length, bond angle, we bring the concept of hybridization. Now we are saying with hybridization, we say like this. We are talking about still methane. With hybridization, we say like this, कि अरे 1s orbital of hydrogen and 1s orbital of carbon and 3p orbital of carbon, 2px, 2py, 2pz, all were having one unpaired electron after excitation. Do you remember? Correct. Okay? So after excitation, these all orbital were having one electron, and then you were overlapping with hydrogen. Hydrogen came, overlap, hydrogen came, overlap, hydrogen came, overlap. So one bond formed by SS overlap and 3 bonds formed by SP overlap. But from this, the practical data or the actual feature of molecule is not explained. So what we say in hybridization, we say like this. First, these are 4 atomic orbitals. These 4 atomic orbital are having similar energy. Okay, they will first intermix before bonding. They will first intermix, mix. 4 atomic orbital mixing, and then they will generate 4 hybrid orbital, new set of orbital, fresh ekdam made, new set of orbital made like this. This will be known as sp3 hybrid orbital. It will make new set of fresh orbitals which are looking similar shape, equivalent. They will say equivalent shape, size, energy. Like this, they will make 4. Like this, they will make 4 hybrid orbitals. 4 atomic orbital combining to make 4 hybrid orbitals having equivalent shape, size, energy. Like this. First, this is happening. देखो, now all are same. There is nothing like S, there is nothing like P. There is sp3. This is sp3 hybrid orbital, sp3 hybrid orbital, sp3 hybrid orbital, sp3 hybrid orbital. Why I am calling sp3? Because one s orbital and 3 p orbital intermixing. See, we can give you simple example. मान लो भैया, I am having 4 chocolates. One chocolate I am having Perk. Other chocolate I am having Dairy Milk. Other chocolate I am having 5 star. And the fourth one dark chocolate is there. Okay? 4 chocolates are there and 4 students are also there. Now everyone saying, sir, I want dark chocolate. Ab batao bhai, how I can give one dark chocolate to everyone? 2 people will say, sir, I want dairy milk. I am having only one. If I will give Perk to him, then these 3 saying, sir, you are giving different to them, different to us, sir, doing partiality, sir, not good, sir. His chocolate better, my chocolate not good, my small, his big. Many problems coming. Huh? So what? Share, then also the problem, na? Means 2 variety you will have. 2-3 variety you can have. So what is the option, you know? Array, you open all these chocolates. Mix, full mix nicely, ekdam intermix, mix. And make 4 new chocolates. 4 new chocolates without brand. Let's call it Gosalites chocolate. Let's call it Gosalites chocolate. 4 exams, same shape, same size, look wise, taste wise, all same. 4 chocolates we have made, Gosalites chocolates. And now I will give these chocolates to everyone. Bolo bhaiya, now there is any fighting? No. All got same chocolate or not? Yes. All happy or not? Yes. All got same taste or not? Yes. Same amount or not? Yes. No tension. Life chill. So this only we are doing here. Before this, you were saying, sir, 2 variety coming, sir. 1 bond is stronger. Rest 3 should be different. So what I said, I mixed all. And I made a new set of orbitals. Those are known as hybrid orbitals. See, all are same. Na? Energy, all same. And now what will happen? These 4 hybrid orbital will align themselves. Vesper theory applied by. Vesper theory applied. Now these 4 hybrid orbital will align themselves in such a way to minimize repulsion. So now you tell, when 4 bonds are there, in what geometry they align? Tetrahedral. So this is tetrahedral, and everyone having one electron. Now hydrogen will come. This is hydrogen atom with 1 electron, and it will pair up. Like this. So now can you see, this is methane molecule. These yellow 4 lobes are 4 hybrid orbital. Smaller lobe is of no use, so we are not showing. It is here only, small, but not showing. So now can you see all the bonds are same or not? Yes. Angle is 109. All bonds same. Angle how much? 109.5. So these all things are explained by hybridization. Okay. Now if I ask you, this bond, sigma bond, is formed by whose overlap? This bond is formed by whose overlap? So now you will not say, sir, S and P. This is not P. Yellow one is not P. That is sp3 hybrid orbital now. So you will say that this bond is formed by overlap of S and sp3 hybrid orbital. I can write here 4s sp3 overlap. This one also sp3 overlap. sp3 orbital coming from carbon side and s orbital coming from hydrogen side. S orbital coming from hydrogen side. Finally, all the points explained. ठीक है, done, hybridization over. But the point is this, कि this hybridization is a hypothetical concept. Like I have explained you, in the same way scientists also explained. All points explained, then they say, "Arey, these hybrid orbital and all not existing only. This is only my mathematical calculations and all." So hybrid orbital don't exist. Hybridization don't exist. It is a hypothetical concept. एक बार देख लो, everyone see this. Then I will write all the points of hybridization which are there in NCERT. Everyone check, see all these things. Everyone take out NCERT. All okay? All okay, okay, okay? Okay. So let's see NCERT now. 6-7 points were there. Do you remember in the last class? Hybridization. So everyone take out NCERT, hybridization section. We will exactly explain those points. We'll exactly write those points. Okay. So see, these things we are discussing. First off, we will try to copy paste exact definition in NCERT, whatever definition is there. This. So this is the definition of hybridization which everyone should know, and there are few points also which we have to take care. Salient features of hybridization. Okay, everyone read all those points, C, every point you have to see. We will explain all these points now. So these are 4 points. Okay. So let's begin. ठीक है? Okay. आ जाओ. So first point what they are saying, it is intermixing of orbital. Intermixing of orbital. Which orbital? Atomic orbital. Intermixing of atomic orbital having similar energy. Slightly different can be there, or we will say similar energy should be there, like 2h2p nearby only. ठीक है ना? So similar energy is there. To redistribute the energy. To redistribute the energy, we are making a new set of orbital, na? So someone having less energy, someone having more energy, we are redistributing, and every one energy is becoming same. So we are redistributing the energy. And how we are doing this? By formation of a new set of orbital. By formation of a new set of orbital, hybrid orbital we have made, which are equivalent in energy and shape. Which are equivalent. So redistribution of energy takes place. Finally, new set of orbital you are having, who are having what? Equivalent energy and shape. Clear? Then they have written one example. Fine, good. So now next point, salient features of hybridization. They will tell you here which atomic orbital can take part in hybridization, how many atomic orbital taking part, then how many hybrid orbital formed. So all these points will be present here. Like what we are saying, देखो यहाँ पे ध्यान से, they are saying number of hybrid orbital is equal to number of atomic orbital. Like I have shown you before only. Can you see I have written how many atomic orbital participating? 4 atomic orbital participating. How many hybrid orbital you are getting? 4 hybrid orbital you are getting. So number of atomic orbital intermixing is equal to number of hybrid orbital formed. Whenever you will have sp3, means 1 s orbital and 3 p orbital, they will intermix. They will intermix. ठीक है? They will intermix to form 4 sp3 hybrid orbital. So whenever one atom is sp3, that means it has 4 sp3 hybrid orbitals. Clear? So same number of atomic orbital and hybrid orbital. The hybrid orbitals are always equivalent in energy and shape. We have made same type. All 4 you can see. All 4 you can see clearly same energy, same shape. Equivalent energy, equivalent shape. Equivalent word used in NCERT. Okay. The hybrid orbital, this also you'll have to take care. This point important. Ki while bonding na, hybrid orbital is better than atomic orbital. Like you are knowing, suppose you are having atomic orbital. This is any p orbital. ठीक है भाई, fine. Where is the electron cloud? Electron cloud is here also. Electron cloud is here also. You can say sir 50-50. ठीक है. Now when we are coming to overlap, you will get some portion of the electron cloud because it is distributed on what? Both sides. But have you seen the shape of hybrid orbital? Shape of hybrid orbital is like this. One lobe almost negligible. The whole electron cloud is in one direction. One side, one lobe. Now when you will overlap, you will get more electron cloud. Like suppose you are going to one party, veg one side, non-veg one side. Now what? You will have to go this side also, you will have to go that side also. You will eat less. But मान लो suppose in one row only veg is also there, non-veg is also there. What will happen? You will start going this side, you will enjoy everything. Na? So whole electron cloud, electron density is here. So overlapping will be better. So they will ask you ki which one is better in overlapping, atomic orbital or hybrid orbital. What will be your answer? Which will be better in overlapping, atomic orbital or hybrid orbital? What will be your answer? Hybrid orbital. That's only we are saying. Clear to everyone? Okay, done. Ab aa jao last part. See the last part, which I said. What I said before, कि once you have made the hybrid orbitals, then you have to apply Vesper theory. कि these hybrid orbital will align themselves. If two hybrid orbital are there, sp, then they will become what? Linear. 3 are there, then trigonal, planar. 4 are there, then tetrahedral. So they will align themselves. The hybrid orbital are directed in space in some preferred direction to minimize repulsion between the electron, thus a stable arrangement. Okay? So the type of hybridization indicates geometry of molecule. So we have said sp3, then tetrahedral, sp, then this, and so on. Okay? Clear? So in future you will find like this, कि suppose I am taking example of BF3. So BF3 is having 3 sigma bonds. Steric number 3. Its hybridization is sp2. Boron, central atom hybridization I am talking, it is what? sp2. Then can you imagine how this sp2 hybridization happened? You will have to think, sir, one s orbital and 2 p orbital, they intermixed. How many atomic orbital, bhaiya? 3 atomic orbital intermixed to generate new set of 3 hybrid orbital. To generate new set of 3 hybrid orbitals, which are equivalent in shape and energy, which are equivalent in shape and energy. This is hybrid orbital. How many formed? 3. How many atomic orbital? 3. So number of atomic orbital intermixing is equals to number of hybrid orbital formed. So can you tell me, when sp hybridization is there, then how many hybrid orbital will be there with the atom? If sp hybridization is there, then how many hybrid orbital with the atom? देख के बताओ, see on the board and then tell. Two hybrid orbital. अगर मान लो, if I am saying कि I will give you example, SF6 is there, SF6 steric number 6, hybridization sp3d2. How many hybrid orbitals are there with sulfur? How many hybrid orbital with sulfur? 6 hybrid orbital. Which hybrid orbital? sp3d2. 6 sp3d2 hybrid orbitals. 6 sp3d2 hybrid orbitals. Clear? So because in future they will also ask you hybrid orbital and pure orbital number, so we will tell at that time. Okay, let's go to the next point. So next point they will write again here, important conditions for hybridization. Important conditions for hybridization. Important conditions for hybridization. In what condition, who can take part in hybridization, and all these things they will say. Okay, so see here everyone, many points we have already said. Like see this point, first point, which atomic orbital will take part in hybridization? Valence shell. Which orbital will take part? Valence shell orbital. Orbitals present in the valence shell of atom are hybridized. First point. Second point, any orbital you can intermix? No. Orbitals having similar energy, slight different, can intermix. So almost equal energy should be there. Atomic orbital having almost equal energy are hybridized. Almost equal energy are hybridized. Third point here important, many people are not able to understand. Can you tell me the meaning of third point? Batao. You can write in the comment section. Can you tell me the meaning of third point? What is the meaning of third point? Bolo, what is the meaning of third point? Excited state is not necessary for hybridization. Hybrid can even occur in ground state. Very good. Excitation not essential. Correct. Very good. So this promotion of electron means what? Promotion means excitation. Like in carbon I have done. You have seen in the last class that carbon was having 2 unpaired electron. But I required 4. So I have jumped 1 electron. है ना? I have done like this. नहीं? Excitation we have done. 2s2, 2p2 was there. So they are saying this excitation is not compulsory. मान लो if you want to form 3 bonds and you have already 3 unpaired electron, then hybridization not required. Like I will give you example. See ammonia. Let's explain the hybridization in ammonia. You are knowing now, okay, sir, ammonia is Ab3L. Ab3L, very, very important example. From this, we will explain 2-3 points. See carefully. Okay, so configuration of ammonia is 1s2, 2s2, 2p3. This is 2s2. This is 2p3. Bolo, how many unpaired electrons are there in ammonia? 3. And how many unpaired electrons are there for nitrogen? 3. And nitrogen is making 3 bonds. I am having 3 unpaired electron and nitrogen is making 3 bonds. So I don't need to excite. As it is, I will take this whole part. Acha, S compulsory. S orbital in hybridization compulsory. All names we have written sp, sp2, sp3, S compulsory. So देखो, where this question is very important, I will show you. All these orbitals will undergo intermixing hybridization and they will make 4 hybrid orbital. They will make what? 4 hybrid orbitals. They will make 4 hybrid orbitals. देखो, these are 4 sp3 hybrid orbitals. 4 sp3 hybrid orbital having 1 electron. But one orbital will have 2 electrons because this pair is present there. Now these 4 hybrid orbital will align themselves in tetrahedral manner. And then hydrogen atom will come and overlap with opposite spin electron, hydrogen, hydrogen, hydrogen. And this is that lone pair. So lone pair is in hybrid orbital. Ammonia lone pair is present in sp3 hybrid orbital. If you will find shape, shape is only due to bonds. So the shape is trigonal pyramidal, and this lone pair is present in, bolo, they will ask you question कि अरे in ammonia lone pair is present in pure s orbital, true or false? In ammonia lone pair is present in pure s orbital, true or false? False. It is not present in pure s orbital, it is present in hybrid orbital. Clear? So promotion, have I excited? No, because I don't require 3 unpaired electron there, 3 bonds I require, form it. So promotion is not compulsory. Last point, again very important, out of which one thing I have already explained. They will tell you which orbital can take part in hybridization. So just now you have seen half filled taking part or not? Yes. Fully filled taking part or not? Yes. And one more point you can add, you will see in class 12 ki empty orbital can also take part in hybridization. So it is not necessary that only half filled participate in hybridization. In some cases, even filled orbitals can take part in hybridization. And you can write here, filled orbitals or empty orbitals can also take part. So half filled, fully filled, empty, all orbitals can take part in hybridization. Half filled, fully filled, empty, valence electron orbital, valence shell orbital can take part in hybridization. I have just shown that in ammonia, fully filled orbital is taking part in hybridization. Is it clear to everyone? Now everyone, once see all these points. So it is almost over. You can see it. Okay. Done. So now in NCERT, when you will go, they will give you one by one example for every hybridization. You should see all these things, ki how BeCl2 is formed. You should read. And one more point is there, ki sp hybridization is also known as diagonal hybridization. Sp hybridization is also known as, see here, sp hybridization is also known as diagonal hybridization. Diagonal hybridization. Clear? Okay, then we will explain you the next part of NCERT. From this also, you will have to see these examples. They go BeCl3, just now I told you. sp2 hybrid orbital. 120 tetrahedral geometry. Fine, Pani. Now we are going to explain this paragraph. One paragraph is here. Dekho, can you see this paragraph? Acha, this table we have already made. Acha, about these compounds you will study in coordination compound. You are knowing this, long-term people. So now I have to explain this paragraph. hybridization of elements involving d orbital. This paragraph, what is the conclusion? This paragraph, what is the conclusion? Okay, so many things are written. Okay, fine. What is the conclusion of this paragraph? Okay, let's see. What is the conclusion of this paragraph? Can you see it? Chalo. So what they are saying now, here some coordination compound points are also required. See, we have 3s, we have 3p, we have 3d, and then we have 4s, we have 4p, we have 4d. Clear? One point we have said in hybridization key orbitals having nearly same energy, slight different, not much gap. Nearly same energy will take part in hybridization. So see, every time orbitals of same shell will take part in hybridization, we don't have any problem. 3s, 3p, 3d, all are orbitals of same shell, third shell. Okay, so they will take part, slight difference energy is there. 4s, 4p, 4d, they can also take part in hybridization, no problem. They are orbitals of same shell. Clear? Okay. But then if you remember, long-term people, if you remember, then you will find कि sir in coordination compound na D2sp3 type of hybridization, DsP3 type of hybridization were also coming, where you were using d orbital of inner and sp of outer. Do you remember? DsP2, D2sp3, these things were coming. That means I can take 3d, 4s, 4p also. I can take 3d, 4s, 4p also. They are having, means fine, here there can be a bit energy gap, but permissible limit. Now if you will think like this, कि sir, can I take 3p in place of 4p? See, here energy increasing like this. Nah? So you can think like this, ki 3d energy is now similar to 4s and 4p. 3d energy is similar to 4s and 4p. So I can take this set also. But now they are saying, ki, can you take 3p in place of 4p? Means, is this set possible? 3p, 3d, 4s. Then they say no. They are saying कि between 3p and 4s there is large energy gap. Large energy gap. So you cannot take this set of orbital. You cannot take this set of orbital for hybridization. You cannot take this set of orbital for hybridization. This is the point. Clear to everyone? Bolo, done? ठीक है ना? You can understand this like this. कि देखो, you can understand like this कि this is a 10th class child. This is 11th class child. This is 12th class child. ठीक है ना? Now 10th, 11, ठीक है, they understand each other, 1 year gap only. 11th, 12th, ठीक है, no problem, same mentality is there. But 10th and 12th, there is large gap. 10th class child, student free. 12th class, so much tension. ठीक है ना? So this is happening, you can think. So they will give you question like this, कि which set of orbital cannot take part in hybridization? And your answers are, options are 3s, 3p, 3d, 4s, 4p, 4d, 3d, 4s, 4p, and 3p, 3d, 3s, 4s. 3p, 3d, 4s. 1, 2, 3, 4. Bolo, what is the correct answer? So the correct answer is fourth one. All of you are able to understand this point? Then that's it. Over. Clear? So our target was to tell these things only. Now let's do some questions regarding hybridization and all. Okay? You have to do all these questions. Xenon F4, Xenon O3. How to solve hybridization questions? I3 minus NO2 plus. We will find many points in this. N3 minus NO3 minus, like this. And what you have to tell me, I am writing all those points. You have to fill up this table. First I will write here general formula. Then I am interested in steric number. From steric number you can quickly tell me hybridization. And then I am interested in telling, kahan chala gaya? Then we are interested in telling shape of molecule, shape, structure, geometry. And in some cases, if I will ask you total lone pair, then you can tell that also. Clear? Now how to do these questions? How to do these questions? See carefully. Dekho, Xenon F4, then I have told you, Vesper theory we have said, first you write AB4. Because 4 sigma bond to compulsory. First you write AB4, 4 sigma bond compulsory. Okay. Then what? We will search for lone pair. Don't forget to search for lone pair. 8 valence electron of xenon minus. Can you tell me what I will do here? Minus. Halogen generally form 1 bond, oxygen generally 2 bonds, nitrogen 3 bonds. We have to think in this way. Minus 4, you will get 4 electrons left. 4 electrons means 2 lone pair, AB4L2. Steric number 4 plus 2, 6. Hybridization sp3d2. Shape, electron pair geometry should be octahedral, but shape after 2 lone pair you will get square planar. After 2 lone pair you will get square planar. Okay, then I am doing this I3 minus question. Can you tell me in I3 minus I should write AB2 or AB3? Batao. I should write AB2 or AB3? I should write AB2 or AB3? AB2. Many people say, sir, I3, AB3. Array, you have to think like this, ki one I connected to 2 other I. AB3 means total atom how many? 4. Are you having 4 atoms? No. So this is AB2. One I, central atom is also I, terminal atoms are also I. This is the problem here. So I will write AB2. Then I will search for lone pairs. Okay, how to search? Iodine central atom, 7 valence electron, 1 negative charge, plus 1, 8. 1 electron will be given to 2 iodine, 1 1. So minus 2. How many left? 6 electron. 6 electron means how many? 3 lone pair, Ab2L3. Steric number 5. Hybridization sp3d. Electron pair geometry TBP. Electron pair geometry TBP. But you will put 3 lone pairs, so it will become linear. Lone pair you have to put on. Now see the diagram. Lone pair you have to put on equatorial position, and when you will draw, its shape will come like this, linear. If you will find the formal charge, -1 comes on the central atom, so this is linear. We have already said that this L tells about lone pair on central atom, 2 lone pair, 3 lone pair. In this they also ask you total lone pair, so you will have to say 9. Total lone pair 9. Now hope you can do all these questions. Okay? If you will have problem, then again send me the questions. Chalo, one last question. Tell me this one. मान लो suppose you are having xenon O2F2. Can you tell me hybridization of this xenon O2F2? Xenon O2F2. बताओ, hybridization and shape. You have to tell hybridization and shape. You have to tell hybridization and shape. Seesaw? sp3d. Okay, how we will do? First we will write AB4. First we will write AB4 because 4 atoms connected. 4 sigma bond confirm. Then I will write here 8 minus. Oxygen will take 2 electrons. So 4 gone. Minus. Fluorine will take 1 electron, 1 electron. 2 gone. How many left? 2 electron. That means 1 lone pair. So AB4L. AB4L means steric number 5. Electron pair geometry should be TBP. But the shape in TBP you put 1 lone pair. You put 1 lone pair. So shape will come seesaw. Acha, how to draw the shape? Let's make the shape also. We have said lone pair and double bond will occupy. Lone pair and double bond will occupy equatorial position. More electronegative atom will occupy axial position. All these things we have said. So this is the diagram of xenon O2F2. This is the diagram of xenon O2F2. Okay? Molecular geometry should be TBP. We will modify that. We will modify that. So I think now it's over. All these things. PCl5 excitation is done. So you have to read all these things once. SF6 excitation done. Okay, all these points you will have to know. They are writing the same thing. You can try all these examples once. Okay. Now we will move to the next part, which they have changed in the sequence. Next part is Lewis dot structure. Lewis dot structure, formal charge and all. Now see, many points you are already knowing after so much practice, sir. Now I can draw a structure anyhow. I don't require these rules now. But man, suppose sometimes if you are not able to draw the structure, then you can take help of these things. What are the rules? See carefully. find total valence electron. Find total valence electron considering charges. Considering charges. ठीक है. Second point they will say find central atom. बताओ who is the central atom generally? First point, it should be less electronegative. Second point, less electronegative. Second point, can form more bonds. Can form more bonds. 2 bonds, 3 bonds, 4 bonds, 5 bonds, like this. And third one is present less in number. Present less in number. Generally it will be less in number in the compound. And the last point, hydrogen and fluorine can never be central atom. Hydrogen and fluorine can never be central atom. मान लो suppose you are having something and you are not able to make the diagram. For that we are having this rule. For that we are having this rule. ठीक है. Then next point are also there. एक बार देख लेना. We will apply all these points, then you will come to know. Connect all terminal atom to central atom by single bond. Distribute the electron. Distribute the electron to terminal atom to complete octet. Doublet in case of hydrogen. Give remaining electron to central atom. What is the meaning of all this? I will tell you. And finally we have to find formal charges on each atom. Find formal charges on each atom. These are the rules. See, till now in Vesper theory we have already made the shape. Okay? We are already knowing many things. But how to draw Lewis dot structure if you are not knowing, or some difficult compound is there, then how to proceed? Actually this topic is written before in NCERT, but we are teaching later. ठीक है. तो जैसे मान लो, let's see all these points once you see these points, then we will take example and then we will try to solve. ठीक है. Once you see all these examples, okay, let's see. Let's start with the diagram of ClO3 minus. अच्छा, ये ज्यादा हो जाएगा तुम्हारा. चलो ZnF4. First let's take single bond cases. We will keep two things in mind. First point कि I should complete the octet of central atom. I should try my best to complete the octet of central atom. And second point we have to keep in mind कि if second period element is there like carbon, nitrogen, oxygen, fluorine and all, then octet should not be extended. This also we are knowing कि second period element cannot have more than 8 electrons. This also we have to keep in mind. ठीक है. जैसे मान लो suppose you are having ZnF4. First you will find total valence electron. So total valence electron is 8 plus 7 into 4. ठीक है ना. So 28 plus 8, how much it will come? 36. 28 plus 8, 36. Then find central atom. Xenon is the central atom. Then what we have said, connect every atom to the central atom, terminal atom to the central atom by a bond. I have connected by a bond. Clear? Now, when you are using these bonds, how many electrons you have used? You have already used 8 electrons. So how many left now? 28 left. They are saying कि distribute these 28 electrons to the terminal atom to complete octet. देखो, this fluorine already having 2 electrons in shared form. So I will give 6 electrons. 6 for 24 given. Still 4 electron left. Those 4 electrons you give to central atom. This question only we have just done before some time like this. कि अरे AB4 है ना, AB4 and 2 lone pair left, put 2 lone pairs. है ना? So like this. This is the structure. Now you will find formal charges on every atom. Formal charges on every atom. So in this topic, the only new point is formal charge. Rest alternative methods are there, you can do. But formal charge we will have to see. Now you can see that there are 4 sigma bonds and 2 lone pair. So this is in fact AB4L2 only. You can write the hybridization also, sp3d2. Clear? Let's go to those questions where we have double bond. Like let's make diagram of CO2. How to proceed with double bond questions. See how we are already knowing कि sir CO2 तो like this we are knowing. We have done like this कि carbon valence electron 4, 2 electron this side, 2 electron this side, done. But according to this rule, how we can make? According to this rule, how we can make? You will have to think like this, sir. First total valence electron. देखो यहाँ पे देखो. This is alternative method to draw diagram. When you don't want to use your brains, simple rules wise, you can use this method. Total valence electron how many? बताओ. जल्दी बताओ, how many total valence electrons are there? So 12 plus 4, that is 16. Correct? Carbon is the central atom. Connect one oxygen here, one oxygen here. 2 bonds you have made. So 4 electrons gone. 4 electrons gone. 4 electrons gone. Now how many left? 12. 6 electron to this oxygen, 6 electron to this oxygen. Now oxygen octet completed. But carbon octet is incomplete. Carbon octet is incomplete. So my target is to complete octet of carbon. How I can complete octet of carbon? You can think, कि sir, this na, the lone pair, here one lone pair is there. देखो, oxygen octet, 6 non-bonding electrons and 2 bonding electrons, 8. Take these 2 electrons and make a pi bond. When you will do like this, you will find that there is no problem to oxygen. Oxygen is still 8 electron. Oxygen is still 8 electron. But now carbon is happy. Carbon is having 3 bonds, 6 electron. Now you can say, sir, 4th bond also I can make. How I can make? Like this. Okay? So now you will find that everyone's octet is complete. Very good. 8 electrons are there. You can also tell hybridization. Ki, sir, this is the AB2 type of molecule, sp hybridization. Central atom, 2 sigma bonds, linear. Clear? देख लो. Now let's write formula of formal charge. Have you seen the formula of formal charge in NCERT? In NCERT they are saying like this कि मान लो suppose there is a compound like carbonate CO3 2 minus. This 2 negative charge is not on a single atom, it is on complete atom. This negative charge is on complete atom, complete molecule, you can say complete molecule as a whole. First line of NCERT only. In formal charge they have written ki the charge which you see on an ion, that is not on a specific atom, it is on the complete ion. Complete, this is having -2. Now it's our duty to find ki how this charge is distributed. So for this they have given you one formula in NCERT कि formal charge is valence electron in free state. Free state means what? When it is not bonded. Like oxygen, free state, how many valence electron? 6. Correct na? You can tell from group number. 16 group, 6. Phosphorus, how many valence electron? 5. Phosphorus, how many valence electron? 5. ठीक है? Boron, how many valence electron? You will say sir boron तो 13th group 3. ठीक है? So valence electron in free state minus they are saying कि number of non-bonding electrons, non-bonding electrons means the dot lone pairs which you are seeing, those are non-bonding electrons. Minus, अब देखो I will show you here, half number of bonded electrons. Half of bonded electrons. They are saying like this, half of bonded electrons. Okay? Next class we will show you formal charge from NCERT. In NCERT where which points are written. Okay? Now let's try to understand this last part. Ki half of number of bonded electrons means what? Listen carefully. मान लो suppose you have a bond, single bond between AA. Can you tell me how many bonded electrons are there? बताओ तो. How many bonded electrons are there? How many bonded electrons are there? How many bonded electrons are there? 2 bonded electrons. Half of the bonded electron means what? 1. So instead of saying this much, ki half of the bonded electron, can you directly say number of bond? देखो यहाँ पे again you see, मान लो there are 2 bonds. So how many bonded electrons are there? Listen carefully, then I will tell you ki what is wrong in NCERT. How many bonded electrons are there? 4. Half of the bonded electron. So answer is what? 2. You can directly say number of bonds. Correct or not? Again, मान लो suppose you are having 3 bonds. How many bonded electrons are there? 6. What is the answer coming? 3. So you can directly say na ki sir number of bonds 3. So in place of this, you can also write number of bonds of that atom, not total bonds you count, of that atom. Number of bonds of that atom. whose formal charge you are finding. Now what is there, you know, in AP, Andhra board, NCRT, combined one, track 1, track 2, both combined, both book. There what they have written half this and they have written this, ki half number of bonds. So this is wrong, na? Either you write half number of bonded electron or you simply write number of bonds. They have written half number of bonds. So wrong. Half number of bonds, wrong. Okay? Now let's see ki how to apply this. How to apply this. Let's make diagram of ozone. Last question. Let's see. Ozone came in paper this year only. Cancelled NEET. How to draw? First you will write total valence electron. Total valence electron how many batao? 18. Then you will write central atom. Then you will connect all terminal atom to central atom. Dekho, 3 steps done. When you are connecting, 4 electrons used, 14 electron left. These electrons first distribute to terminal atom. Done. 12 distributed, 2 left. 2 electrons you can put on the central atom. All rules I am following. You can also follow it. Simple, simple, simple. Now you will find, sir, this one octet completed, this one octet completed. This atom octet not completed, oxygen. Middle oxygen, central oxygen, octet not completed. So how to complete octet? Remove 1 electron from here. You can do from any side and make a bond. Dekho. Now you will find here, sir, now go, okay, octet completed. Achha, now we have to check formal charge on every atom. Like if I want to find, dekho yahan pe how to use the formula. If I want to find formal charge on this oxygen, suppose in NCRT they have marked, okay, this is 2, this is 1, this is 3. So if I want to find formal charge on second oxygen, then how to find? See the formula. Total valence electron in free state. Oxygen, free state O. How many valence electrons? 6. Minus non-bonding electrons, non-bonding electrons, how many? 6. Minus half of bonded electron, or you can say number of bonds. This oxygen, how many bond? 1 bond. That's it. Don't count all the bonds, sir. 3 bonds are there. We have written formal charge we find for every atom. So you have to just see this atom. So it is coming -1. So the charge on this oxygen is -1. Can you find the charge on first oxygen? Middle one, central one. Bolo, what I should write? You tell. Middle one, central one. What will be the formal charge? You will again say, sir, valence electron in free state. That to same. 6. Minus. What minus I should do? Number of non-bonding electrons. Number of non-bonding electrons. Number of non-bonding electrons. 2. Very good. 2 dots are there. These are non-bonding. Minus number of bonds. Tell me quickly. Twarga Chapandi. Minus number of bonds. This oxygen having 3 bonds. 3. So +1. So central oxygen has +1 formal charge. Can you find for the third oxygen also? You will say, sir, 6 minus 4 non-bonding electron and 2 bonds, so 0. oxygen is not having any formal charge. Third, oxygen is not having any formal charge. Here we have 0, like this. From this question we can generalize also कि whenever oxygen is having single bond and 3 lone pairs, there is a minus charge on it. When oxygen is like a normal atom, 2 bonds, 2 lone pair, no charge is there. And whenever oxygen has 3 bonds, 1 lone pair, there is a positive charge on this. This you can generalize. This you can generalize now. At many places we will see these things. Okay? Can we do one more question? Carbonate. Everyone try this last question. You can tell the hybridization also now. If you want to tell hybridization from the shape, you can tell. Dekho, 1 sigma, 2 sigma, 1 lone pair. So this compound is Ab2L, sp2 hybridization. Carbonate. Everyone try to draw the diagram by seeing the rules. Total valence electron you will tell, then central atom you will connect. Bolo, how many total valence electrons you are getting? 4 plus 18 minus 2. Minus 2 means 2 extra. 24. Okay. Then single bond connected. 24 minus 6. 18 electrons left. Then what you will do with the 18 electrons? What you will do with the 18 electrons? These 18 electrons you will distribute to the terminal atom. All finished. देखो, all finished. Now see, oxygen octet completed. Is carbon octet completed? Central atom carbon octet completed? No. Then how to complete its octet? By making pi bond. We complete the octet by making pi bond. Make one bond here. Now okay. Now okay. Then over. All over. Octet completed. You should not exceed the octet of second period element. Now you will find formal charge. You can find formal charge from this. You will get here 6 minus 1. So minus 1 on this atom. Minus 1 here. That's it. We have already said that whenever oxygen is there, single bond, 3 lone pair, minus 1. Single bond, 3 lone pair, minus 1. You can generalize it. Is it clear to everyone? So that's it for today. In next class, we will write the theoretical points of formal charge and we will go to coordinate bond. After practicing some questions we will practice based on this Lewis dot structure, and then we will move to coordinate bond. Bolo, clear, all clear. Resonance also we will see, don't worry. So this what we have written a Lewis dot structure. Now it is not compulsory for you. This is like an alternative. If you can do without it, you can do. But if any structure, if you are trapped, sir, NO2 minus I am not knowing, NO2 plus I am not knowing, then you can try this method. I am giving you some questions which are very important, coming again and again, and students are trapped in this. like NO2, देखो all are similar looking, that's why I'm giving you NO2 minus, NO2 plus, NO2 minus, and NO3 minus. Try to draw Lewis dot structure of these three. You will get something in this. Okay? So try on your own. Otherwise, in next class we will draw. Okay? Now take the QR code. What is the highest marks in PACE? PACE 2 marks given, na? अरे भाई, हाँ 720. Page 2 marks, how much you got? I was asking. Online, how much marks you got? Write your marks once. Online students. ठीक है? अच्छा, you don't want to write, you can skip also. Chalo, enough for today. Revise the things, see the video once again. Speed slow, you can increase, decrease, your choice. Okay, thanks everyone. Bye bye.